So, Mr. Bohr, you are going to explain and elaborate more things for my students so that they can understand your surfing boating model. So, tell us now, finally. Okay, so Niels Bohr is telling us that imagine that there is a small wave and there is a bigger wave. So, from a small wave, when you decide to go on the bigger wave, what do you need to do? The word that comes is jump. So we need to jump from this surface to this surface. And what that jumping needs? Energy. So when we have high energy, we can jump on bigger waves, means higher orbits in this case. If you consider it as first orbit, so this is second orbit, and this is what the energy we are applying. So you can go on the higher stages. When you lose the energy, you comes down again. So this is what happens continuously on the basis of the energy exchange. When you lose the energy, you comes down. When you gains the energy, you goes up. So when you gain more energy, you can go further up on N3 and so on and on. So this is the very fundamental of the thing. So energy is related to N square, as I already told you. So where this square comes, well, we are going to explore that a little later. But for now, we have supposedly see that energy is directly proportional to the orbit. Like in the first orbit, the energy is proportional to 1 square. In the second orbit, we require the energy of 2 square, which means proportionality is 4 here. In the third one, it is 9 and so on. So energy is increasing as much as the orbit we are increasing. So this is something like photoelectric effect, as we have already studied in dual nature of matter radiation, right? Okay, I think you get the point. Now let's see what are the key points that is given by Niels Bohr. So first point here is that we are going to see the postulates given by the Bohr. Electrons don't radiate energy in orbit's revolution. When electron is revolving around the nucleus, it is not going to radiate an energy because the orbit itself is having energy. So why do it needs to radiate? Now the second point is L is equal to nh by 2 pi. N is orbit here and L is angular momentum. We are going to see its derivation in the last of this video series. Now in the third one, we can see it seems like photoelectric effect, and exactly that is photoelectric effect. You can write also like this, which means kinetic energy is way worse. Okay, so you can use any way you want. You can just remember this three postulates of the Niels Bohr. Well, this is one of the most important thing when you have to write the Niels Bohr's postulate, and especially the second one, because this is one of the greatest discovery of the Niels Bohr. This is the observational one, and this is, as you can see, photoelectric effect. So definitely Einstein is there. So that's it for Niels Bohr's postulate one. Now we are going to see that what is the mathematics given by the model and challenged by the Bohr. Like we are going to have a condition, a match one-on-one match. Now it's time for revenge between Niels Bohr and our Rutherford. So who do you think is going to win this match? Well, he's not so much happy. He is angry. This is Rutherford and this is Bohr. So we're going to have a dual match of maths. So this is intellectual war, and we're going to be the witness of this amazing historic war. So stick with me to know about the war. Take care. God bless you.